Hello friends, today I am going to discuss about correlation coefficient. Correlation coefficient measures the amount of linear dependence between two variables. For example, the amount of linear relationship between height and weight, demand and supply, or you can say marks obtained in statistics and mathematics, etc. To understand the linear relationship or any type of relationship between two variables, preliminarily we draw scatter diagram. So let me consider some hypothetical examples to let x and y be two variables, x1, x2, etc. x1, y1, x2, y2, etc. xn, yn be the n pairs of observations. Then the Carl-Pearson's coefficient of correlation is given by covariance of xy divided by standard deviation of x and standard deviation of standard deviation of y. Now let me consider my example. X takes the value 1, 2, 3, 4, 5 and y takes the value 5, 7, 9, 11 and 13. If I draw the scatter diagram, you can see that all points lie on a particular line. That means there is strictly linear correlation coefficient between x and y. Then what is the correlation coefficient between x and y? That we can see by using the formula. We obtain that correlation coefficient between x and y is +1. Let me consider another example. X takes the same values 1, 2, 3, 4, 5 and y takes the value 13, 11, 9, 7 and 5. Now you can see the scatter diagram. It is slanted like from above to the bottom, okay, from above to bottom. That means as x increases, y decreases. In the earlier example, as x increases, y increases. And again, there is a strict straight line relationship between x and y. The only thing is, as x increases, y decreases. Now, if we calculate the correlation coefficient, it will turn out to be -1. Okay. Let us consider another example where we have marks in statistics, say 5, 3, 5, 3, 4 observations let me consider, and marks in let me consider marks in statistics means something like oral examination, you can say, out of 5. Then marks in mathematics, let me say 3, 2, 3, 2. Now the scatter diagram is on 5, when x is 5, I have 2 points, 3 and 2, and when y is 3 and 2, in fact 3 and 2, let me say y is 3 and 2 and 4 and 3, let me say. So when x is equal to 5, I have 2 values of y, 3 and 4, and when x is equal to 3, I have again 2 values of y, that is 3 and 2. Now again there is a kind of linear relationship, but there is no perfect linear relationship. When x is equal to 5, y can be 3 or 4, and when x is equal to 3, y can be 3 and 2. That means a kind of relationship, and again increasing relationship. As x increases, y also increases, but there is no perfect relationship between x and y. For a particular value of x, I cannot give a particular value of x. X and y value, y value may vary from different. In this case, I have taken only 2 values for x, so I will get, if I take many observations, I will get different values for y for a single value of x. So in this case, you can see the scatter diagram, there is a very high linear relationship between x and y. as x increases, y increases. Then if I calculate the correlation coefficient, of course the correlation coefficient turns out to be, you can see we can calculate by using Carl Pearson's correlation coefficient. It will turn out to be square root of 1 by 2. Okay, so that means there is a very high correlation coefficient between x and y. So in another example, let me consider the correlation can be of, positive nature, correlation can be of negative nature. When it is of positive nature, as x increases, y also increases, and when it is of negative nature, as x increases, y decreases. Now let me consider another example. In this case, let me take x is equal to 5 values, x is equal to 1, 2, 3, 4, 5, and y is equal to, now let me take y is equal to something like 11, 9, and again 9, 11, and again 9. Now if you calculate the correlation coefficient, you draw the scatter diagram, you will see that you cannot say as x increases, y also increases, or as x increases, y decreases, anything of that sort. You can see from the scatter diagram itself. That means there is no linear relationship between x and y. I can say there is no, of course in this case there is no relationship, but in particular there is no linear relationship between x and y. If I calculate the correlation coefficient, now the correlation coefficient turns out to be 0. So whenever there is no relationship between or dependence between the two variables x and y, then the correlation coefficient is 0. Now let me ask the question in the reverse way. If the correlation coefficient is 0, can I say that there is no relationship between or there is no dependence between x and y? Let me consider another example. X is equal to -2, -1, 0, 1, 2. Now y takes the value 4, 4, 1, 0, 1, 4. Now if I calculate you can see that if I calculate the correlation coefficient turns out to be 0. Now let me see the scatter diagram. There is perfect relationship between x and y. When x is negative, y decreases, and when x is positive, y increases. In fact, I cannot say that there is a linear relationship between x and y. But if I say, I can write when x is equal to -2, y is equal to 4. That means y is equal to x square. Okay, y is equal to x square. The relationship is new. Y is equal to x square. That is quadratic relationship between x and y. So the correlation coefficient says only that there is no linear relationship between x and y. So when correlation coefficient is 0, don't come to the conclusion that there is no relationship between x and y. From the scatter diagram, you can find out what type of relationship it is there. If it is non-linear, then you need not have to go for correlation coefficient. Definitely the correlation coefficient will be 0. So important thing here is, in between any two variables there can be positive correlation. That means as x increases, y increases. There can be negative correlation as x increases, y decreases. There can be no correlation. No correlation means there is no relationship. There is no linear relationship between x and y. It does not mean that there is no relationship or dependence between x and y. So what we have learned today is the correlation coefficient gives the amount of correlation between x and any two variables, say x and y. So amount of correlation means it need not be either 1 or -1. It can be anywhere between -1 to +1. So when the correlation coefficient very close, absolute value of the correlation coefficient is very close to 1, we can say that there is high linear dependence between x and y. When the correlation is 0, we can only say that there is no linear dependence between x and y, but when there is no relationship between x and y, there is no the correlation coefficient is 0. Okay, today we have learnt about correlation. There is further thing what we can study is regression. Regression actually estimates the value of one variable given the value of the other variable. We can do it in some other class.